Good morning again. We will continue from where we left last. So last we were discussing about the process of object-oriented design, and it has three activities. We learned that there are three activities. One is refining the use case model to reflect the implementation environment. Basically, the analysis use case is now transformed into a more implementation specific use cases. So after we identify the new things that need to be added into the use case, we redefine the class interactions, the different interactions and behaviors, new attributes that support that new use case. The final stage is updating the class diagram to reflect the implementation environment. Now, based on the updated use case information, we have to now either update or create new class diagrams. So basically the third step is to create the class diagrams, updated class diagrams. So once the objects and other interactions have been designed, class diagram can be refined to represent software classes in the application. A design class diagram means a diagram that depicts classes that correspond to software components that are used to build the software application. So basically, targeting the implementation environment, we design the new classes. So to quickly understand that, so when we say a class diagram, if you look at a UML class diagram, you will have classes defined, then the associations or any other type of relationships between the classes also specified. Each class will have its attribute and the type of the attribute. Then it will have the methods and parameters. Then for these attributes and methods, the navigability, basically that public, private, protected, those access modifiers. And also if there are any classes dependent on another class, that those dependencies will also be defined in a class diagram. So to quickly go through, this is the same note from your book they have given. So in this particular activity, the third activity in this process of designing, so once you have modeled the relationships and all in the use case with that CRC card and sequence diagram, we come and first add the new design objects, basically the new classes we create. We add the attributes as the second step, you can see here. Third is we add the attribute visibility. Yes, so I mentioned, I think navigability as a different thing. No, navigability is something else, I'll explain that. Attribute type information we edit, then we attribute visibility. So this is the visibility part, the public, protected or private, we mentioned that. Similarly, we start adding the methods for that class, what that class is going to do, basically the setters, getters. I think basic of these things you might have already learned in Java, how you design a Java class with private variables and public methods. So then within those methods also you decide which is going to be public, protected or private. Then you add association navigability between classes. Add navigability arrows to unidirectional association. Basically navigability, we are telling which class is going to send messages in which direction. So unidirectional or bidirectional, that information we show in the class. And finally any other dependency relationship. So if we look at a typical class diagram, so these letters are not clear, ultimately it will be looking like this. We will have all the classes separately defined, and you can see these arrows indicate dependency. That means this class is dependent on this class is dependent on this, like that. And also you will have this association line here. For example, if you look at this says it's a bidirectional association. This active member place new order handler is bidirectional association. But if you look at this one, you have an arrow mark here, which says only one direction this can interact. That means active member can just call member ordered product, but not the other way around. Basically, member order product cannot call any of these methods here, right? But he can call this person. So that is what this small arrow mark mentions. So similarly, a member ordered product can talk to the product, but not the product can talk back. So those kind of navigability associations can be shown. So ultimately, a UML class diagram will look like this. So this may be only for a particular functionality oriented class diagram, because if you take the whole system UML class diagram, there will be many classes. So it might be very difficult to put it into one sheet, but you have software applications where you can put them into one sheet and have a look. But generally what people do is they take classes that are relevant to one particular problem area. So for example, this is mostly related to order management. So they take all the classes related to order management and put it into a single UML diagram, and similarly for each and every other use case, maybe they will have separate UML classes. So that's about the third activity in designing an object-oriented diagram. Right. So then we move on to another important topic area about object reusability. Now, when you are involved in system design, you shouldn't duplicate your work. As much as possible, you should be able to reuse existing implementation. If you have defined a class, for example, let's say you have a class called member, and that member class, you shouldn't be creating another similar class with a different name which has the same attributes and same behavior. That means it is duplicating. So in that case, we have to carefully analyze and see why this thing is happening, and you should avoid that kind of scenario. As much as possible, we should be able to use our existing objects for certain scenarios. So in object-oriented design, we try to achieve, when we are designing classes, low coupling and high cohesion. So what is coupling? Coupling means the degree to which one class is connected to or relies upon other classes. That means a class should have minimal number of associations to other classes. That means a class shouldn't be dependent on many other classes, or it shouldn't be connected to many classes. So when we saw this diagram here, this UML class diagram, now for example, now this place new order handler, sometimes if you look at this, it has associations to many classes, right? One here, one here, one here. As much as possible, that kind of a scenario should be avoided, right? So that is what is coupling is telling, low coupling. So we have to have a class which is self-sufficient. It should be able to be on its own. Cohesion means the degree to which the attributes and behaviors of a single class are related to each other. That means, again, it talks about encapsulation. If you remember encapsulation, so an attribute should be accessed by its own method, not by somebody else. So that kind of a design is called high cohesion, right? So in object-oriented design, we try to achieve low coupling and high cohesion. We'll try to understand this with another example, which we'll be discussing in a few minutes. So the reasons behind high cohesion and low coupling is each class focuses on one thing. That means one responsibility. It shouldn't take multiple responsibilities. And classes should be independent as much as possible, as I told. Then object reusability. Object classes created for one information system should be able to reused in other information systems, right? So this is what is the main objectives. Similarly, talking about design patterns, object-oriented developers look for the same reuse opportunities through the use of design patterns. So while we talk about low coupling and high cohesion, that leads us to a discussion called design patterns. Now in the software design industry, there are many patterns which are used again and again. So altogether, I think there are about only 23 different patterns being used in different ways. Out of the 23 patterns, there are a lot of sub patterns created, right? So when I say a pattern, it's something that we uh, generally use in our daily life. Similarly, in software world, there are some patterns. Now, for example, to easily understand something, now um, you might have when you're making a tea, you use a filter, right? Where you filter out the tea separately, and when you pour the when you mix the tea and water, sugar, everything, and then before pouring into the cup, we don't pour it directly, we use a filter. So that pattern we say it's a filter pattern. Similar technique we use in many things. So that is one case where I mentioned about tea. But if you look at that same pattern, same thing you use for maybe your mineral water. So when you are pouring water, you may have a filter that is filtering out the pure water. Or let's say when you're having this piti flour, when you're buying it at retail store, sometimes rather than the packet flour or packet piti, what we do is we have mostly at homes they have this small filter kind of thing where you have to shake it off and take out the germs and worms separately. So there also we are using a filter. Like this, there are certain patterns which are common, which we can reuse. One place we use that idea, again in another place also we can use it. So in software world also, software design also, we have similar patterns like that. So design patterns means a common solution to a given problem in a given context, which supports reuse of proven approaches and techniques. So this is the important point here, reuse of proven approach. That means it is already done and tested. Already people know this will not fail. Those kind of things are known as design patterns. Common. So it will give a solution to a particular problem in a particular background, particular context. Right? So that you will later on in your life, maybe you will learn more of these design patterns as you go. So today we will be discussing about just 2 or 3 patterns, which will give you a highlight into how this object reusability is being used. Okay, before I come here, let me explain the high cohesion low coupling example. Right. Okay, if you look at this figure, I don't know whether you can see it. Okay. Now this is a sequence diagram for place new order, right? Now to understand this, you have a couple of objects written at the top. I think later we'll be learning sequence diagram. So you have the member class here, you have the order window interface here, place new order class, which is a controller class, member order class, member order product, and product. Then you have mentioned the interactions that is happening. So member class is trying to make item selections through the order interface, which in turn calls a method add item, which is available in place new order. So when we say add item, It is passing two parameters, item and the quantity. So this method is available under this place new order class. And if you look at this blue color rectangle altogether, it says it's a loop. We'll be learning this also later. So when we say it's a loop, this operation, selecting items, can happen multiple times because we don't know which one is going to return the correct item. So this has to go in a loop. Then if you see, place new order is making a call to the product class, where product class has a method called calculate quantity in stock. By passing the product number, we are able to get them, and then product is directly returning the quantity in stock to the place new order, right? So this calculate quantity in stock is a function of the product class. It is a responsibility of the product class. Similarly, then if you see, after that again, they're sending the product number and the quantity ordered. Then member order class is calling itself multiple times. This is called another loop to calculate the total. And then I think it is calling another function out of member order product here, calculate extended price. And this again gets the price information from the product and returns it here. Then finally the member order class returns a message to the place new order, and then again that returns the message to the order interface where the member can receive it. So if you look at this, each of these classes have their own responsibility. They are doing their own thing. Now if we move to an alternative of this class, or let me show it here. Okay, it's the same diagram in a different way. Here, if you look at the difference, instead of place new order directly calling the product, you are giving the responsibility of calculating, calling this calculate quantity in stock to the member order class. You're giving more responsibility to this person. And again, this member order, you can see, is calling also member ordered product to get the product details. And then again, getting the price details. So you can see the member order class is now dependent on how many classes? Looking at these calls, how many classes do you think the member order is now dependent on? Earlier you can see member order was only talking to one class here, just calling this method, calculate text price item. What this method is, this calculate text price item was a method from member ordered product. But now if you look, the same member order class is making a call to the product, is making a call to the member ordered product, then again yes to the product. So he is now involved in interacting with more than one class, which means, in other words, high coupling. But in our proper object-oriented design, we have to achieve low coupling. Low coupling. That means a class should be very minimally dependent on other classes to get some information, right? So this is a bad design, basically. It's not a good design. I wouldn't say it's a bad design, but it's not a good design, right? Also, if you look at this particular method call, this calculate quantity in stock, it is not the responsibility of the member order. It is the responsibility of member ordered product, because member order class should be responsible only to give information about orders, and it shouldn't be doing the calculations. It should be handling only information about orders, but calculations is not part of his responsibility. So that call should be delegated to the next person here, member ordered product, right? It would be more appropriate if this method is called under this one. So in that case, we can say this is low cohesion. That means we are doing something which this shouldn't be doing, right? So that is what is described in the following slides, I believe. We go back. So here, that same points explain here. So when you have this place new order calling here and this person calling this one, this places more responsibility on member order entity class, which is making the coupling high. So coupling should be low generally. And place new order controller does all the work here. So if you look at this one, high coupling, member order is related to more classes, as I told, and lower cohesion. Member order is responsible for getting the quantity in stock out of product, which is not the responsibility of the member order. So it shouldn't be doing work which it's supposed to do, which it is not supposed to do, right? So we have to be careful what this order class should be doing. It should be handling orders only, not to do any other calculations or anything else, right? So this is an important point. So keep in mind, we have to achieve in object-oriented design low coupling, high cohesion. So what is coupling? The amount of dependency we have with other classes is called coupling. Cohesion means the amount of relationship between a class's attributes and its behaviors is called cohesion. So here we can see clearly this calculate quantity in stock is because this quantity information is there in the product, which is not in the member order. So when we are trying to do something externally like that, clearly we say it is not the responsibility of this person because this attribute is not here, right? So in that case, it is lower cohesion. So we have to achieve high cohesion where a class should be responsible for its own attributes and doing the behaviors to those attributes only. Okay, let me go back to the point here. So coming back to design patterns, some definitions. A pattern is a recurring solution to a standard problem in a context. A recurring solution, a repeating solution to a standard problem. A pattern describes a problem which occurs over and over again in our environment and then describes the core of the solution to that problem in such a way that you can use this solution a million times over without ever doing it the same way twice. So this is what we try to achieve in a pattern. So basically a pattern means something that you do once and you can be able to use that concept or that particular pattern again and again. Now a very good example would be, now if you have implemented an interface in this operating system, already they have done that. So when I click on this print thing, it may be showing me information related to a PDF printing option here. But from here onwards, selecting the printer and clicking on printing and calling the rest of the printer related functionalities, that might be done only once in the operating system. I don't have to worry about whether I have to implement that separately or not. So that interface is already, that particular printing functionality is already implemented as part of the operating system, and different application to application we are reusing that. We are not doing something new, right? Maybe this interface is new, but the functionality behind that is going to be the same. We are reusing. So that's one way to understand that. Okay, so when we talk about object-oriented design patterns, it was popularly introduced by these 4 people, who are known as the Gang of 4. You search the internet, there are plenty of things. Why they got this word is they started they wrote a book called Design Patterns. That is where they introduced the 23 different patterns, and that was a very popular book. Later adapted into Java, C#, and many other object-oriented programming languages. Right. So if you can see, C++ and Smalltalk are some early object-oriented programming languages. So they wrote that book based on that, and so that is what is known as Gang of 4. So what they mentioned there, the problems and solutions are broadly applicable, used by many people over many years. So why is it useful to learn about this pattern? Patterns suggest opportunities for reuse in analysis, design, and programming. So as a software architect, we don't have to invent something new. We simply can go with these existing identified design patterns that are already there and keep doing our work properly. If people follow these patterns properly, they will achieve reusability. That's what this Gang of 4 people mentioned. So when we look at a pattern, these people describe, this Gang of 4 people mentioned that when you look at a pattern, it has essential 4 elements. One is it has a name. Second, it has a problem where this pattern can solve. So describes when to apply a particular pattern. And what is the solution? Describes the elements that make up the design, their relationships, responsibilities, and collaboration. Finally, by using this pattern, what are the consequences? That means the goods and bads. So what would be the outcome? Are the results and the trade-offs of applying the pattern. So these are some 4 attributes of a design pattern. Okay, again revisiting, 2 overall goals of object-oriented design are low coupling, high cohesion. Coupling, the degree to which one class is connected or rely upon other classes. Cohesion, the degree to which all of the attributes and behaviors of a single class are related to each other. So we achieve low coupling and high cohesion. This is the overall goal. So we want to achieve reusability of classes. That is what is achieved by low coupling and high cohesion. So the benefits of object reuse is, I think, explained here. Several studies have documented the success of object reuse. So in this paper they have mentioned Electronic Data Systems, it's a company. They initiated 2 projects to develop the same system using 2 different languages. So PL1 and Smalltalk, you can see this one has taken a longer project duration and lot of effort in person months, and also the software size, because I think it's a procedural language. It has taken about 265,000 lines of code for the same system. But when they used the object-oriented language such as Smalltalk, it has taken a relatively or drastically very low project duration, and everything is low, effort is low, and software, the lines of codes are also very less. Reason being is mainly we are reusing the objects again and again within the different parts of the system, right? So this is one of the advantage you can see in an object-oriented programming language. So Java is an object-oriented programming language, C++, C#, PHP. You are learning JavaScript as well, that's a web-oriented one. That is also object-oriented language. It all derives from basically C++. So in design patterns, they guide you as don't reinvent the wheel. It means do not write software to solve a problem that someone else has already written to solve correctly and efficiently. Means if already something is there, there's no point in going and doing it again because it's already there. A pattern is already there. We just have to use that pattern. So many companies take this approach for developing new applications. So it will save their time and money. Object-oriented developers look for the same reuse opportunities through the use of design patterns. Well, even from a software developer point of view, it's very easy for them because their life will be easy. Otherwise, they have to think about a new pattern to solve a problem. Instead of that, they can just refer to these things. All these pattern explanations are available online, many websites. One very popular one is this tutorialspoint.com. You can see all the different types of patterns that are available. I think all 23 patterns plus the sub patterns are also available here for reference. So as a software developer, we just have to go and look at those patterns based on our problem, which pattern is more suitable, and then use the class implementation in that bit. So the goal of a pattern is not to discover or invent a new solution to a problem, but to formally structure an existing solution to a common problem, right? So we are not inventing a new solution. We are trying to solve a common problem with an existing solution so that others may use it and take advantage of it. So you shouldn't confuse design patterns with these things. One is sometimes in your Java programming language, you might have heard about linked lists, hash tables, or arrays, collections, and all. These are data structures, obviously, but you can't tell that those are patterns. Although we reuse them, we reuse that structure in our code. That is not called design pattern. That is not what we are talking about. Again, design patterns are not going to solve specific designs, domain-specific designs. No. Design patterns are something that is applicable anywhere in any software scenario, right? So that's how you have to understand design patterns. So they divide design patterns into three categories: creational, structural, and behavioral. Creational patterns means it deals with initializing and configuring classes and objects. Wherever you have a pattern like something is getting created, something is being configured or initialized, you may have certain scenarios in your software. In those areas, you can use creational design patterns. Structural patterns means you have to deal with decoupling, interface, and implementation of classes, objects, composition of classes, objects. Now, for example, you have a need of creating superclass, subclass facilities, or like you have a need of you already have a structure and you want to go and fit into that existing structure. That kind of a scenario, we use structural patterns. Then you have behavioral patterns where you have dynamically changing interactions. So like during the runtime, you may face certain scenarios where you have to behave differently for different environments or different scenarios. In those cases, we use behavioral patterns. So they deal with dynamic interactions among societies of classes, objects, how they distribute responsibility. So these are the, I think, 23 I don't know whether 23 counts up here. You can count and see later. Categorized into the three categories: creational, structural, behavioral. So under creational, the most popular design patterns are this factory method, prototype, and singleton. Under structural, most popular one is adapter, decorator, proxy, facade. Under behavioral, chain of responsibility, uh, observer, strategy is most popular. I think out of strategy, others also kind of similarly share the same idea. To briefly, so today we'll be discussing as part of your syllabus, mainly the singleton, adapter, and strategy. So once you understand how each are working in a simple way, it'll be very easy to understand the rest as well. Apart from that, just to start with observer pattern to give you an idea. Now imagine you're using Facebook or you're using WhatsApp, right? In WhatsApp, like you get this notification. Now, for example, it's showing me 16 here, right? Or even in my Gmail, it is showing the number of emails here. Whenever a new message comes, this changes to 17. So how is that happening? So that is happening because of a observer pattern implementation of the classes or whatever the objects that are done there, right? So it's like you have an object talking to another object and notifying. So one object is observing the other object. When that object changes, first object changes, the other objects that are subscribed to that are automatically getting the notifications. So that pattern is called object notifier pattern, right? As mentioned here. Okay, so we'll start with singleton pattern. You can forget about this class diagram and all. I think if you go to tutorials point, you will get the proper class implementation details here. I'll briefly explain what is singleton pattern. Let me zoom this a little bit. Singleton pattern is one of the simplest design patterns in Java, C# everywhere, all the object-oriented programming. This type of design pattern comes under creational, as this pattern provides one of the best ways to create an object. This pattern involves a single class which is responsible to create an object while making sure that only single object gets created. That means it involves a single class which is responsible to create an object while making sure that only single object gets created. This class provides a way to access its only object, which can be accessed directly without need to instantiate the object of the class. Okay, so let me quickly explain what they are talking here. Now, generally, let's say if you have a person class defined, and when you want to access object out of the person class, we normally do like this. No? We create P1 equal to new person, something like this, right? And maybe if you have person P2 and if you assign P1, now if I ask a question, are P1 and P2 the same? You might say, what is the answer? Are these two same or different in terms of the memory you have learnt in Java? Are the same or different? When we when we write the code like this.
It's different 2%.
2% classes, yeah, object definition is different, but when you do like this, we pass by reference, no? Normally we are referring to P2 is now pointing to the memory location of P1.
P1, yeah.
So it's again the same person again. But sometimes mistakenly we could do like this also. If we did it this way, let's say by example, we may have some confusion like this, and then we might say, okay, P1 is equal to P2. Maybe this is also, sorry, P2 is equal to P1. Maybe this is also the same. But still, there is a possibility that P2 can be reinitialized again. P2 can be, once we do this, now this reference is lost. Now this is going to create a new memory location again, right? So we may run out of, we may come across certain confusions, whether P2 is the P1 or whether it is a separate one in our code. To avoid those confusion, if your software application has a need that when we say P1 and we want to get the original P1, only that particular P1, in that case we use a singleton pattern, right? So singleton pattern will ensure when we are implementing, if you go through this code later, you'll understand, it will get the original instance for your application. That means if you define an object and you want to get only that version of the object, you have to use singleton without any other copies or references. A good example, real world example would be a very popular example. Imagine you are designing a chessboard application. So in a chessboard, you have the chessboard and you have the chess players and you have the different whatever that objects you play in the chessboard. So each of these can be defined as separate classes in your Java program. But regardless of the players and regardless of the number of objects that are moving there, the board is going to be the same because the game points need to be updated to the board. So that board is going to be single. It is only one thing. So when you are referring to board, you can't refer to board 1, board 2, anything like that. It is the same board. So in that case, that board has to be defined as a singleton pattern. Wherever we are trying to access the chessboard, it has to give the chessboard of that particular game, because you may have multiple games, game 1, game 2, game 3, like that. But whenever you are referring to board, it should be from that particular game domain only, right? So this is where that is one example where we use singleton pattern. So we want to refer to that original object. If you have a need to refer to the original object that was created first, the only way to access that object is through if you have implemented it through a singleton pattern. So that is singleton. I hope you got the point. Another thing is proxy pattern. This comes under structural patterns. So first we'll briefly understand what is structural pattern. Describe ways to assemble objects to realize new functionality. That is added flexibility inherent in object composition due to ability to change composition at runtime. Okay, not possible with static class. You can't do structural patterns with static class composition. So structural patterns give a way that, let's say you have a already arranged set of classes and your software is working perfectly. Now you want to come and add new functionality without changing any or with minimal changes to the existing one. If you have followed structural pattern, it will be very easy to introduce a new change into the system. So to simply understand, just understand in that way. You have a already fixed structure in your application. You want to add a new scenario. You want to come and fit into you want to fit a new situation. In that case, structural pattern will be the most. The structural pattern will permit that. So one particular example is proxy. So proxy, meaning of proxy means working as a representative of somebody else, right? So proxy means acts as a convenient surrogate or a placeholder for another object. So proxies can come in different varieties. Remote proxy, that means local representative object in a different address place. Let's say you have a class that is part of a server, and from your client application you can't access the server object, but you can access the remote proxy object, which is like an interface to that original one. Similarly, virtual proxies there represent large objects that should be loaded on demand. For example, if you have memory intensive applications where a lot of memory is going to work, the original object might be taking a lot of memory, but you can create a virtual proxy which will not necessarily load the real object, but it will load a proxy of it for you to work properly. Or sometimes you can implement protected proxy, so protect access to the original object. If you want to avoid external people dealing with the original class, you can always create a proxy class. Instead of making access to the real one, you can make them access through the protected proxy. Let me show that also in a simple way here. Now if you look at this, so again, let's say an explanation. In proxy pattern, a class represents functionality of another class. That's the basic understanding. So you have a class, let's say class A and class B. So class A is our main class. So class B is representing class A. So when you want something to do with class A, you don't talk with class A, you do it with class B, which will in turn do the work for class A, right? So this type of design pattern comes under structural pattern. In proxy pattern, we create object having original object to interface its functionality to outer world. Okay. Now if you look at this, you have this is our main class, real image, okay? And it has an attribute called file name, and when you call this real image, it has a constructor called real image, and it has a method called display, and it has a method called load from disk. So when we say load from disk, obviously we can feel sometimes that's going to take some time when you try to call this method by initializing a real image class. This might take a lot of time to do the work for you. And ideally, sometimes this can be residing in a server side. This code can be in a server. And you can see this is implementing the image interface, right? So image interface has a method definition called display, and you have implemented that method here. Now, instead of making a program access this main class, we can create a proxy image, a proxy of this class called proxy image, which will have a name of it, and it will also have the file name, right? So if you look at real image, it has a variable called real image, which is of type this original class. So within the proxy class, you have a variable of type real image and the file name and its own constructor and the display method. This also implements the same image class. So now what you do is you have your main method here. No? Normally in our console applications, we have a main method. So this main method wherever we have our main program running, instead of initializing real image class, we initialize proxy image. So when we initialize proxy image, it in turn internally goes and creates a real image object for you. So this is called proxy. By doing this, we are avoiding unnecessary delays that can happen in this one, because now a person working with this can do rest of the work in their code without any worries. They don't have to worry about whether this has loaded or not. Otherwise, if you directly access, normally if this is on the server side, it will take some time to initialize. So instead of that, on the client side, we provide a proxy class where any application can use them. So you understood the meaning of proxy, working on behalf of another class. That is called proxy class. Clear?
Yes, I am clear.
Okay. So let me move on. So that is proxy. Adapter pattern. Okay. Let me skip the explanation here. Let me explain adapter pattern through a explanation first. Adapter pattern plug. That's a very good example. Okay. Now imagine, let's take this picture. Okay. Now imagine you have a plug, you have a switch on the wall where you have this socket, you call this socket, right? And then maybe this has a standard interface where you can only plug this 3-pin thing. Now you have a device with a 2-pin plug, okay? But you can't directly put this here. For that, what do we do is, in order to make this work, we use a adapter. That means we introduce a new interface where we can use the main thing here to make use of this. So just because, you have to also understand, just because we have now a 2-pin plug coming in, we don't change the socket, right? So that means for every different type of plugs, we have to create different type of sockets. So that is not going to work in the real world. Even in our real life, that's not possible. We have to, in our homes, we may have just only a single plug, but we have to use a different adapter to, plug it in. So this pattern is known as adapter pattern. That's why, because we introduce a new interface called adapter, and then facilitate that different scenario. So for this one, this will work. Maybe for another type of switch, you don't have to change the socket. You just have to introduce a new type of adapter to support that particular plug, right? So depending on the new scenario, you introduce a adapter to it. So that is what is called adapter pattern. So in adapter pattern, we don't change the main functionality. We introduce a new interface for external objects to come and fit into. So to understand that with the example in your business scenario, here. Now, I think this is the same explanation given here. Now, Soundstage member services system has to calculate sales tax on orders. Keeping up on all the varying laws in the country or province is a difficult task. So let's say each province has a different type of law. So ultimately your system is same, but you have a different laws going to come in. So whenever new law is coming, we should be able to adapt to that law. So in that case, if we can handle this tax calculation. Basically, tax is going to change. So tax calculation may be different from province to province. So if we introduce the tax calculation part as an adapter, your main system won't change. You just have to use the correct adapter to make that work. So that is what is explained here. If you look at this now, member is dependent on a sales tax adapter, which has a class called, which has a method defined called calculate sales tax. So now this adapter is not going to change because this is going to be where the member order is going to talk to. Now for a particular brand, let's say brand X, brand X sales tax calculate. Now for brand X, there is a calculation class that calculates the tax. So to use this class, you introduce this relevant adapter. So for example, you want to charge your mobile phone again, you may have to use a adapter your brand of mobile. Maybe an Apple phone adapter will not fit into a iOS version of the phone, right? So each device will have its own adapter. Similarly, if you want to use a particular functionality, you have to use that particular adapter and make it fix it into that particular scenario. So in this case, you can see a particular province wants to use brand X sales tax calculator. So you create an adapter that will depend on that calculation, and you make this generalized to the sales tax adapter. So whenever you want to change your, let's say your registration system is going to another province, the only thing they have to change is this particular area. This particular area or this particular area, both, because they have to get the relevant calculating class as well as the adapter class. Imagine if this idea was not there, if these two concepts are not there, they have to keep on changing this again and again. I mean, this whole functionality they have to change. For each type of adapter, they have to keep on changing the logic, because now here the logic is not here, logic is going to be here in this area. The calculation logic is going to be here. So you don't worry about what you are calling here. You just call one class here and the adapter will take care of it. So in any new scenario, you just have to change the adapter. You don't have to worry about the others. This is called adapter pattern. So adapter pattern describe ways to assemble objects to realize new functionality. So again, explanation given here. So it addresses the problem how to provide a stable interface to similar classes with different interface. Solution is add a class that acts as an adapter to convert the interface of a class into another interface that the client classes expect. So here we converted this interface into another interface so that it was able to do its own work. Same example given there. So it provides an unchanging method, calculates sales tax, right? You don't have to worry. Same scenarios with your payment gateways as well. When you're doing payments online, now I have seen certain payment gateways. I may be using the same website, but at different times it goes behind the scenes for different payment gateways. Sometimes it goes to HNB, sometimes it goes to Sampath, sometimes it goes to commercial. But from my website, it is the same method I call. I just click a button, like, proceed transaction or something. But you have different adapters depending on, I think, the availability of the payment gateway, the relevant payment gateway comes and pops up in my browser. So that is also another example of adapter pattern. Right. So to integrate it in the purchase class, brand X sales calculator. This is the purchase class. We write a new class called brand X adapter that inherits from sales tax adapter class. So the idea is you introduce this class which will talk to the relevant purchasing class. So it explains if we ever change the vendors or the points, then we have only to write a new adapter subtype. So only this has to be changed. Everything else stays the same. Whatever the remaining things stays the same. Right. Then we move on to behavioral patterns. This deals with dynamic interactions among societies of classes and objects, provide guidance on the way in which classes interact to distribute responsibility. That's called strategy pattern. It's type of behavioral. The main one is strategy. So in strategy pattern, we try to address how to design for varying and changing policy algorithms. So you have a system that you have a scenario where your system within a given context can change to different conditions. This is different from what we discussed on the adapter. Adapter is like you have a complete new scenario, you don't want to do change, you just introduce a new thing. But when you have a strategy pattern, it is like dynamically you have different patterns. Within the same domain, you have a live scenario, one person doing something in one way, another person in a different way, but ultimately they are going to do the same thing. So for that kind of scenario, we introduce strategy pattern. The solution is define each algorithm in a separate class with a common interface. Now, very simple example to understand. If you take transportation, modes of transportation to an airport is an example of a strategy. Several options exist, such as driving one's own car, taking a taxi, an airport shuttle, city bus, or a limousine service. So, for example, if this is the thing you want to achieve, you want to go to airport, you provide the time and cost, for example. To go to the airport, you have many options. So whenever you have a thing like optional in your system, you have to think about strategy pattern, nothing else. Like now, for example, in your system, you will have this payment option, very popular one, right? So you will decide cash, check, credit card. So these are provided as options. So you can design them as strategies. So maybe you will have the common payment class here. Then you have the subclasses derived from it, right? So in this case, you can see for transportation, you have many strategies. So any of these modes of transportation will get a traveler to the airport and they can be used interchangeably. The traveler must choose the strategy based on the trade-offs between cost, convenience, and time. So in a real example, let's say a company X is running promotions. When a member places an order, may use any number of promotion options. The promotions can be based on total dollar amount of the order, or based on number of units they have purchased, or based on the kind of the product that has been ordered. Some provide based on the discount, some amount is some dollar amount discount. It might be a fixed amount. So you can see you have many options to do the promotions. So the way to think is to put each of these as separate classes and inherit them from a common theme. Right? So it's a strategy pattern. So explaining that programming code to apply to each kind of promotion is significant. More importantly, it is constantly changing, new promotions from marketing. So even if something comes in the future, you don't have to change any of these. So after 5, the 6th type of promotion can be just implemented and fit into that existing scenario. Okay. So that is called strategy pattern. So basic thing you do in that exam again, how can the system incorporate existing and new promotions without constantly rewriting code or classes? So without changing anything at the top, how can you introduce a new thing? So easy way is to add a new class and just inherit from the main class. So it becomes another strategy. Example of that promotion class. So you can see promotion class is common. It has a method called calculate discount, whereas you have different type of promotion calculation methodologies. One is total dollar discount. Those 5-6 examples I mentioned, I have mentioned only the 3 here for easy understanding. So each class has a standard interface method called calculate discount to return the dollar. And each will have its own implementation of calculate discount. Right? You inherit from here, but if you take this one, this will have its own calculation. It will have its own logic and also its own attributes, as we have learned in superclass subclass concept. Right, so that explains strategy pattern. So as I told you, they have only described, I think, 3 or 4 patterns here. But in reality, as a good software designer, you should learn about almost all of those 23 patterns when you are doing your actual software. Having an understanding of all 23 is good, but sometimes it's difficult to remember all 23 because there are only few patterns that are used again and again in common scenarios. At least 5 or 6 patterns, having the knowledge of them is easy. I gave you an example of filtering pattern earlier. So filtering pattern also, there is a thing called filter pattern. Like, pipeline filter, you open the water, you have the pipe which provides the water, and then you add the filters. At whichever points you want to filter something, you can filter information. So where do we use this pattern? Normally filter pattern is used in your search. Most websites you have multiple filters. For example, when you're searching, you can tag search only name, then search name and age. So when you're typing the letters, so when you're adding these new filters, it is using behind the scenes filter patterns. Since you may not already realize that you're using a filter pattern because you're using mostly these MVC frameworks that are already done. So all these MVC frameworks are using, I think, majority of these design patterns in their frameworks. So as a developer, sometimes you don't realize it. But if you are doing something new, you have to think of implementing your classes in that way. So hereafter, when you're looking at new softwares, new applications, you have to not only just look and feel surprised of something, you have to now think behind how they have done this. What is the pattern they have used here? This is how you have to think. So this is a good place I would give you for you guys to later refer. Just go to tutorialspoint.com, design patterns. You can go through some of the important. Factory pattern is basically a concept of factory. Like, imagine in a factory you produce things. So some inputs come and outputs get created. So if you have a scenario like that, you can use factory pattern. Prototype, decorator, chain of responsibility. That is one of my favorite patterns. I don't know whether it's here. Yeah, chain of responsibility. This is like you have a scenario where when you're doing some work, if one person cannot do it, how to pass it to the next person. If that person is not responsible, how to pass to the next person until it reaches the person who is responsible to do that functionality. So you may have a pattern like that. You can use chain of responsibility. So just go through this. It will give you a good idea, and that should conclude our discussion on the design patterns. So any questions?